scientists have made a major stride towards turning fusion energy into a viable energy source. The research could allow for the creation of a whole new kind of sustainable energy source that in turn could revolutionize the way we power our world. Nuclear fusion is perhaps best known as the process that powers stars. Researchers hope that it could be brought down to Earth and harnessed as a sustainable source of power. But creating it in laboratories has proven difficult. It uses far more energy than it produces, and so remains largely useless at a large scale. Now scientists say they have successfully built a process that allows for the self-heating of matter when it is a plasma state, using nuclear fusion, which could represent a major step towards the use of nuclear fusion. The research is described in a study, Burning Plasma Achieved in Inertial Fusion, published in Nature today. An accompanying paper in Nature Physics describes how scientists were able to optimize their experimental design successfully. The breakthrough experiment is only an answer to only one of the many questions that surround nuclear fusion, and much work remains to be done. But it satisfied a key requirement for self-sustaining fusion energy as it has been envisioned and hoped for. In short, the researchers were able to compress and heat a plasma, which will then be heated by the reactions themselves, allowing the energy to sustain itself. To conduct the research, scientists took the hydrogen isotopes deuterium, which can be found in seawater, and tritium, which is made in a reactor. They used them to create a burning plasma. In a burning plasma, the particles that are made when the nuclei fuse then become the main source of the heating of that plasma. In 4 different experiments described in the paper, the researchers were able to generate more than 100 kilojoules of energy. In one of them, the researchers got 170 kilojoules of energy from a sphere the size of a millimeter, which contained less than a milligram of the isotopes. Though that is far more energy than was put into the fuel, helping to overcome the perennial problem that nuclear fusion actually uses more energy than it produces, it is still only a relatively small amount in total. The cavity containing the process and the laser required to heat it still use far more energy.